Alright, time for another DraftPhysics.com, debatephysics.com also, but can't find the debate. They're all cowards and weasels, and it just sucks. The internet is garbage because people suck. That's just the truth, anyway, so science sucks because scientists suck. Okay, no other reason. They just lack anything called integrity and honesty and all that kind of crap. They know they're talking shit and they don't give a damn because they're getting paid to do it, frankly. They at least know it's marginal. They know a good argument, right? I say, I make an argument and I say, look, their physics says it takes 25 times the fuel, the energy, the electricity to spin something 5 times as fast. Everybody knows it isn't goddamn true. Everybody knows it doesn't goddamn happen. They all know it. They know they can't demonstrate it. They can't show you any evidence of it. And yet, here we are. They will ignore the argument, run away from the argument, literally, just run the fuck away. And pretend, F equals ma, therefore it happens. Yeah, even though it doesn't happen in reality, it happens because it's our physics and we believe it. It's math. The math says so. Blah, blah, blah. I mean, it's just bullshit. So it's just, like I said, all this is for for what purpose? Like I said, I don't know, who knows if the future is going to even be smart enough to play a video. They won't even know how to hit the buttons. They're going to get dumber and dumber. And these assholes are the ones that are going to make them dumber and dumber. So anyway, so this is going to be on 2 subjects. It just doesn't matter what the subject is because you don't understand just the simplest concept. So this one's about friction. And, and there's two kinds. Okay, it says static and kinetic. So first let's understand the word kinetic is just useless in science because clearly they're using it for 2 purposes. One purpose to talk about things that are actually moving, okay, where you can see the energy, versus places where you can't see it. Okay, and so they call the kinetic energy, the moving energy, there's the obvious kinetic energy, but you can't see the battery energy or some other kind of energy. You can't see the kinetic component, so, the moving parts. And so we just call that some other kind of energy, the potential energy. Because you can't see the stream of gravity you're actually in. We call it potential energy when no, it's just, you're in a stream of force. I mean, even the fact that people just, again, they think that the earth is pulling on them. I mean, it's just so fucking stupid. I can't believe I have to make these fucking videos. And the fact that they call what they're doing science, when clearly it's not science. Science is you get challenged, you answer the challenge. Science is you prove what you're going to claim. You don't sit there and tell people they should believe it because we all do, and we're going to insult you if you don't. I mean, it's just fucking bullshit. These pious authorities telling you what to believe, and then you do it. You're fucking controlled by them. You little weasels. You'll go out of your way to attack me and, fucking fuck with my family, fuck with my private life. Oh, because, God damn it, he's saying something that we don't like to hear. I mean, you're so pathetic. Anyway, God damn, this sucks. It just sucks. I mean, it's hard enough, really unraveling lies and bullshit and centuries of tradition. That's enough work. And you shouldn't have to sit there and first convict you all of being lying fucking goddamn weasels first. Before I can even have a trial, I have to prove that there's no jury on earth that is actually 12 good men. They're all lying scum. They can't actually evaluate and say, okay, it's a good argument. 25 times the fuel to go 5 times as fast. Yeah, it's a damn good argument. 8-pound bowling balls going 16 miles an hour knock down twice as many pins as 16-pound balls going 8. Oh yeah, that's a good argument. The science is obviously fucked if it says that. If science says, then science is full of shit. All right, so this friction argument. Okay, I could draw it, but I mean, the idea is if you understand the elemental universe rationally, I'm just going to argue, it's full of, your cell phone calls, microwave background radiation. There's all kinds of visible light. You can see that part, you dumb fucks. There's all kinds of radiation in the universe. So if I take something and I put it in that fucking universe, okay, and there's nothing else in the universe but cell phone calls and all kinds of shit, what's it happening to it? Oh, it's getting hit all the time. So it's doing this, right? All the time it's getting hit from different directions with little subtle different amounts of energy, but it doesn't really go anywhere because there's just as much fucking universe that way as there is fucking that way, as far as it can tell. And even if there was more universe in one direction than there was in the other direction, the whole thing would be moving that way because of the force. So if the force is going to move the electron in a direction, then the whole universe is going that way anyway, and so you wouldn't notice. But regardless, it's doing this, indicating that the fucking universe is hot as hell. Okay, there's a lot of energy in the universe. Okay, the dead empty space is full of pieces of energy. It's thermodynamically active, right? So now you want to try to build an atom. So you have an electron and you have a proton. And let's say they really, really, really want to stick to each other, but this is fucking happening, you assholes. You see this? This is happening. So every time they try to get next to each other, one of them gets jerked this way, or one of them gets jerked that way. So they can't really stick to each other. And guess what? That's a fucking hydrogen atom. So they're associated with each other. I like you, but we can't really combine because we're bouncing up. And it's like you're trying to shake somebody's hand, right? And you're both in some fun house on little platforms that are vibrating, and you're trying to shake hands, but you really can't do it because there's too much fucking energy in the universe. All right. Well, anyway, so what happens inside of big pieces of matter is that the little electrons and the protons, they're getting smushed into each other. So in the core of whatever massive object it is, it's this intense amount of pressure that is more force. And the more heavier and denser the force gets, the less room there is for motion. The motions are quicker, but you can't go anywhere. You can't do this anymore, right? You can't miss each other this way. You have to miss each other this way really goddamn fast. But you really can get a lot closer, so you can now actually do your handshake, and now guess what? You have a neutron. Okay. And so when they talk about fusion, that they're going to make energy by fusing. No, they're not going to make energy by fusing. Fusing takes energy. Okay, so that's not going to work. And what fusion is actually doing is they're not taking the hydrogen out here that's doing this. They're taking the neutron in here, okay, that's already compressed. And you compressed it inside of a sun. It blew up. A bunch of neutrons flew around. So we're taking neutrons that have already been created in other suns, and they're now in atoms. And so the atom is stable enough where the neutron stays in one piece because it's got a little bit of pressure. And so it's not as jiggly, okay, because it was made inside of a sun. And they're breaking the neutrons. That's fusion. They're not making helium. Making helium has nothing to do with it. It's not the helium. Making the helium atoms is a side effect. It's the waste product of breaking the neutrons. Oh, God, people are just so stupid. So yes, you can build lots of other kinds of atoms, lots of waste products, but the only energy, okay, is gravity. So anyway, all right. So back to this. So the friction argument is really just a thermodynamic one. You can understand it that if something's jiggling and the other thing's not jiggling as much, this thing touches this thing and it causes this thing to jiggle all over the place. So you can understand heat transfer. Friction's the same damn thing. Heat and motion are the same thing. Motion that doesn't go anywhere, we call that heat. Motion that goes somewhere, we call energy. And it's the same damn thing. There's not any difference except one has a differential in a one direction. It's heat in a direction. So a force is just heat in one direction. You get it? And heat is this, where there's no real direction. That's heat. Those are the two alternate states that matter can be in. But they both have to be in one or the other. They have to be either hot or hot moving in one direction. There's just no other options. So all things do when they touch each other is they, by convection, not convection, what's the other word? Anyway, by contact, the heat transfers from one to the other, the movement, the activity, the action. And if the movement is in a vector, then obviously that's what's being transferred, is motion. And so all you're doing is taking something's energy, its force, its differential, its motion, and transferring to something else. The thing loses energy because it gives it to the other thing. They transfer their condition. And it doesn't really matter which one's hot and which one's cold. It's just the only thing that matters is understanding. You don't need to know their absolute condition. You just need to know that all that's going to happen is they're going to share their condition. And in that process of sharing their condition, you'll see one thing slow down and one thing speed up. Little things in the ground move with friction, and big things slow down because they're losing energy to a bunch of little things moving. All right, and then the difference between static friction, your and kinetic friction, where you actually start moving, is just as obvious as the dent in your fucking chair. If somebody was to try to push you sideways out of your chair, or even on the ground, you can understand there's this problem where you've sort of sunk into it. And it's more complicated than that because there's all kinds of electrical bonds that happen. There's all kinds of atoms on your surface, and some of them are compatible with sticking to the other atoms on the other surface, and they actually make a chemical bond. And that's static friction. You've bonded. You've essentially sort of glued to the surface, and you have to break that bond before you can slide across the surface. So yeah, static friction is a real thing in the sense that if you have a constant force pushing you into a surface, or you've been on a surface for a long time, you likely have made some electrical and some chemical bonds to that surface, and you have to break those to start moving something across the surface. So it's not very complicated. Now the irony is he takes 7 minutes to explain friction, which is so fucking simple, and the next video where he's doing work and energy is only 4 minutes, right? Work and energy, like the biggest subject in physics. There's like no more important subject in physics than the idea of energy and this idiotic concept of, energy we like, which we call work. Okay. Can't get a bigger concept though, the word energy. Anytime you see the word energy, that's physics. Physics isn't about anything else. Physics is just about transfers of heat, which is energy.
Professor Dave, let's learn about friction.
He knows a lot about the science stuff. Professor Dave explains.
Yeah, he knows what he's been taught, and then he just propagandizes it to dupes like you. I mean, clearly his professor didn't say, hey, you know what? It does sound like absolute crap. Here, I wrote all these fucking equations on the board, all this nonsense. 25 times the fuel to go 5 times as fast. We all know that's bullshit, right? Did he do that? No. He was taught the draconian learn our catechism, okay? Mary, God, lover of Christ, mother of Christ, or whatever, blah, 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 blah. Learn how to recite the bullshit. And these are people who think Christians are a problem. Yeah, you're fucking just as bad. Dogmatic nonsense preached as the truth.
In examining Newton's laws of motion, we have to understand that the kinds of motion we observe on Earth don't always appear to obey these laws.
Okay, so obviously if the physicist knows that already, all right? They knew that 1,000 years ago. They had already observed that fact in the sense that the moon keeps going around and around and around, or the Earth keeps spinning and it doesn't seem to lose any speed. So they already kind of got the idea that, no, we're in some kind of glue. And the rest of the stuff up there in that dark black stuff, well, in the black places, there isn't any of this gluey atmosphere crap. They sort of figured that out.
Because there are extraneous variables acting upon earthbound objects, and most of these involve some kind of frictional force.
Right, and most of all the friction is in one kind of form, or it's only one form, gravitational. So again, just imagine it all being done in space. And then it all becomes a lot more obvious and easy to figure out.
Friction is an important concept to
I throw a tennis ball at the space shuttle. Do you really think the space shuttle's going to give a fuck? Or do you think it's just going to say, fuck you, take your energy back?
understand. So let's go over it in some detail. Whenever an object is in motion along a surface, the surface exerts a force upon...
So it doesn't exert any fucking force. So again, this is just so fucking stupid. You really can't figure out that the surface isn't doing a damn thing. It's just sitting there minding its own business. And the fact is you're going to heat the surface. You're going to change the surface. The surface is going to start moving. I mean, come on. I have to explain that to you fuckers. There's no fucking force. There's no fucking goddamn frictional force. There's just the fact that you are rubbing against it. There's a pressure pushing you into the surface, and then you have a motion. And there's no way to avoid the fact that you're going to disrupt the goddamn surface. And the more you disrupt it, the more contact you have, the more electrical contact, the more you are, the more electricity can flow. So anybody who's touched any kind of electricity knows that's how it works. A little tiny wire, and it just burns up and nothing happens. And you have to have enough conductor, and it has to make good enough contact for the electricity to flow. And the friction does exactly the same thing. The more your contact, the more wattage, the more you're going to change your conditions. You're going to share your conditions with each other. The plus and the minus are going to equal out. Oh, fuck.
upon the object. One component of this force is the normal force, which...
So there's no normal goddamn force. There's no such thing as a force that everybody has, a normal force shooting up all the time or some kind of bullshit like that. There's just the fact that the puck itself is pushing into the surface. It's got an actual fucking weight. It's got mass. The mass is creating a differential, just like with regular gravity, and it's going to be pushed into the surface. There's no way to avoid it.
Which is perpendicular to the surface. There is also a component of this force that is parallel
and
to
there's absolutely no force going backwards. So again, it's just absolutely nonsense. There's no force going backwards. There's just you giving away your motion. You have it. You got motion. You have energy. And frankly, you can see your energy footprint. You can see the footprints. You get footprints are an example. They're demonstrating the fact that you're leaving something behind. You are doing the work of this walking against gravity. And what have you done? Well, the work you did is you dented the fucking sand. You did fucking work. You're doing work going across the surface. And the work is just sharing a condition. The ground is in one condition, you're in another condition, you're having enough contact to share your condition. So you're going to start moving little bits of the ground in the direction you were moving, and you're going to give away your capacity to keep going in that direction, your energy in that direction, because the little arrows that are pushing you are now in the ground. Duh.
surface, and this is called the frictional force, or simply friction. This is the force that will resist the motion of the object.
So there's no resisting the motion. Again, nothing resists being rich. You have to just give it money. You give it money, it's rich. If you give it money out of your pocket, then you're poor. It has to come from somewhere. The Earth is moving around the sun. Where did it get the energy? Well, obviously it had to get it from something else. Something hit the Earth, shared its energy, the thing stopped moving, and the Earth started moving. That's the way it works. It's not that the thing stopped moving. It stopped moving as fast as it was going. It goes much slower as the Earth goes much faster.
along the surface. Every surface has some frictional coefficient that will vary depending on its composition.
Right. So, and all that it's about is its chemistry and, how much, how cruddy the surface, how rough the surface is. So the more grit I put on the sandpaper, the more you're going to share, okay, your emotion, the more contact you're going to have with little bits of shit, the more you're going to break their little bonds. So the more energy you're going to use up, okay, and the slicker I can make it, the flatter I can make it, the smoother it gets. The more graphite is just a bunch of little flat planed crystals, and the little flat crystals can fly across each other without any, very little loss of energy, because they don't really make contact, they just slide across. They're almost like they're almost like little iron filings magnetically levitated against each other. They don't have any plus minus bonds to make. They don't have any way to connect to each other. So it makes a very good lubricant.
To see this demonstrated, try to push a small block across some ice, and then try to push it across some sandpaper. These materials differ in their resistance to motion.
So again, they're not resistant, and we know they don't have any. It's not like it's a resistance to motion thing. It's about a making contact thing. And clearly, the rough surface has lots of surface area, lots of things to bend and move, lots of things that will bend and move, and so it can transfer a lot of energy.
For reasons that relate to their composition. The smoother a surface is, the less friction it will provide.
So it's not necessarily true. So, you have wet ice, obviously, it will actually create some sort of, vacuum energy in the sense that you'll end up creating a capacity for the thing to actually get stuck, because there's a bond between the water molecules and the ice is good, and the water molecules in the puck is good. So it starts making more and more bonds. So it becomes less free to move, because now it's moving a liquid too. So besides the fact that you're creating waves in the liquid, you're pushing it ahead of you.
Even surfaces that appear perfectly smooth will have imperfections on the microscopic level that provide some friction.
Right, and it doesn't need to be just microscopic lumps. It can also be just charge. So static electricity can create a tremendous amount of friction.
As the object moves across the surface, there are select points of contact where atoms in the object interact with atoms.
They touch, and what do they do when they touch? They share their energy, their motion, their heat. Okay, and again, you're just arguing, just as they would, through conductivity, share their heat, they're going to do exactly the same thing. They're going to conduct, their motion. So the heat is motion, any kind of motion, well, they're going to conduct that. And they're also going to conduct the heat in one direction, the force in one direction.
In the surface, and this attractive interaction hinders motion to some measurable degree, no matter how small. Let's define two main types of friction, static and kinetic. Static friction is the friction that resists the initiation of motion.
So again, it's not resisting it again, it's just the wrong way to say it. It's a condition you've created where, because of the static condition, you're now in a well. You've decompressed, you've made molecular contact, you have created stronger bonds between you and the surface. So the longer the thing is touching, the more likely it is to make a more permanent contact. You can do this in space, because there's no atmosphere to oxidize surfaces. So you can clean two metals really well in space, just rip the surfaces off, and the metals don't oxidize. There's no impurities, so to speak. And then stick the two metal pieces together, and they'll actually make molecular bonds that will be essentially the same as just welding them together. You'll make exactly, a space weld. It's really a thing. Welding in space. It works.
You place a block on a table and try to very lightly push it into motion. It will first resist that motion because of the friction.
So again, it's not resisting the motion. It requires more motion to lift it out of the dent it's created. That's one way of looking at it. Or it takes more energy to break it free because it's had lots of time to, for its little tentacles to stick to the tentacles of the object below. They've chemically become more, you've made more contact. They've seeped into each other. They've glued it to the surface, essentially. You've essentially glued it to the surface, and I have to break the glue.
Frictional force operating in the direction opposite the applied force of your push. You can push harder and it will still remain still, because the frictional force will always precisely oppose the applied force.
Oh, so it's just so silly. The frictional force will always oppose. There's no force opposing anything. It's just a requirement that it takes a certain amount of energy to cause all of the atoms to move, and all of them have to go, right? You can't just move part of the box. You have to move the whole box, right? So the idea is that, you're applying the force, and you have to apply enough force where the object says, yes, this is enough energy for me to move everything. If you give me just a little bit of energy, well, then you just move some of my electrons and protons, and they'll move back again. They'll reflect the energy. Okay, so you have to push the electrons far enough where the whole atom goes with them. And if the other atoms can't go, then the energy has to be reflected.
Static friction will increase until the magnitude of the applied force exceeds the maximum static frictional force the table can exert.
So again, nonsense. It's just the fact that there is a connection. You have to break the bonds. The bonds require a certain amount of energy to break, and that's all there is to it. It takes a certain amount of energy to lift the object out of the well.
Then the force of the push can no longer be canceled out, and the block will begin to accelerate. This frictional force is proportional to the normal force, so the heavier the object, the greater the normal force.
Well, obviously it doesn't have anything to do with the normal force, as you can point out, because if I change the chemistry, it gets stronger and stronger. If I make these static electricity, if I make one of them positive and one of the surfaces negative, I'll end up with even more. So it's not proportional at all. So that's just bullshit. It's not explicitly connected to gravity. It's directly and essentially requires gravity, but there's no connection between the amount of gravity. It's really more about the nature of the surfaces and the chemistry and the electrostatic condition. That will decide.
And the greater the friction.
I mean, obviously, static, you can stick a balloon to a blackboard. You can do lots of things with static electricity and create static friction. And it didn't have anything to do with gravity.
Force. This is because as the weight of the object increases, the harder it presses down on the surface, which will increase the number of contact points between the object and the surface.
Right, but if the surface area doesn't likewise grow, that sometimes is a moot point. So again, there's absolutely no proportional relationship between the weight and the amount of friction. It just doesn't exist. It really does depend on the nature of the surface, how bendable it is, all kinds of things. But there's absolutely no directly proportional relationship to the strength of gravity. And again, static electrical contact proves the point. The friction created by static electricity proves that it doesn't have anything to do with gravity by itself. It's much more dependent on the nature of the surfaces. The elephant is really easy to push on ice, just like the mouse. Okay, it's just, yeah.
Frictional force will be anywhere from 0 to the maximum possible value, depending on the forces operating on the object.
So again, it really doesn't depend on the forces operating on the object. It depends on the nature of the surface and whether it bends, whether it does all kinds of things. It all depends on those things. If it doesn't bend, then yeah, elephant, mouse, same difference. If it does bend, well, yeah, you're going to need a lot more energy to lift the elephant out of a pillow.
Since the static frictional force will be equal to the applied force until the maximum is reached. The magnitude of this maximum can be calculated this way.
Oh, so this is just more their bullshit, that we have a formula. And again, a very imprecise bullshit formula. That's what this US thing is. Okay, that just means we don't really know what the fuck we're talking about, so we'll just make up some U crapola.
F max is equal to the coefficient of static friction times the magnitude of the normal force. This coefficient, represented by the Greek
Yeah, so this coefficient really just has to do with certain little circumstances. Again, the coefficient has nothing to do with anything static or chemical. So any kind of bonds being made because you're rubbing, let's say, copper against copper versus copper against aluminum, it doesn't take into account any of those things, any of those variables, and they're hugely important variables.
letter mu, is unitless and unique to the surface in question. And we have tabulated these coefficients for a variety of common surfaces.
As dopey little standards that they'll never always apply in those circumstances. So obviously there's no such thing as glass by definition. There's all kinds of different glass, right? Gorilla Glass, well, that's the kind, the kind on your frickin' phone screen. All kinds of different kinds of glass with all kinds of different abilities to be scratched and create defects that would allow for friction. So really just a gross approximation, not even close to anything really scientific.
Like glass, steel, wood, and rubber, and the various combinations thereof. As we said, once the applied force exceeds the maximum static friction, the object will begin to move. Bear in mind that this equation involves scalar quantities, not
bullshit. Another bullshit concept. There's no such thing as scalar fucking force or motion or momentum or anything. There's no such thing. It all has a vector. It's all just bullshit. Look, examples. Soft iron versus, hardened steel. Lots of things. Lots of different ways. Graphite versus diamond versus charcoal. They're all going to behave quite differently.
Not vectors, and therefore implies nothing about direction. As we said, static...
It all has a direction, so again, it's just idiotic not to talk about the fact that all motion in the universe on the elemental level is in a direction. There's nothing not moving in a direction. There's nothing going a speed without going a direction. It's all just bullshit. It's inanely bullshit. Again, you're such doopy assholes that you'll let them say shit like this, like somehow something can have a speed without a direction. You'll let them say that?
Friction opposes the initiation of motion, but once an object is in motion, it is now moving against kinetic friction.
Right, and that's when all of those things start mattering, okay? Material, what it's made out of, all this other stuff. So again, the static part can't be... precisely described in the sense that there's so much nuance to how thick the jello is, how much fruit is in the jello. There's no such thing as standard jello.
This is the force that opposes relative sliding motion. Kinetic friction is always lesser than static friction, which you will notice if you try to push any object across a surface, like a heavy box across the floor.
Yeah, obviously, when it's glued, it's more stuck than when it's not glued. So it's that simple an argument. Duh. I mean, fucking duh.
It will be more difficult to get the box going than it is to keep it moving once you've started. There are coefficients of kinetic friction as well, and these will be different from the coefficients of static friction for the same materials.
So those are a little bit bizarre, those numbers, right? I mean, glass on glass. So once you get glass moving, so the argument is again, how pure is your glass, and is it like this made out of the same stuff? Because, the Gorilla Glass actually has a very different surface than regular glass. There's a bunch of different chemicals on the surface. So these numbers wouldn't work because the chemistry is different. So if you put, regular glass on Gorilla Glass, it's not going to have this smoother coefficient. So all this is so fudgeable. It's just so bad. But these are, huge differences. Let's look at ice. Ice on ice. So somehow ice is a lot stickier when you're not moving. Which, again, is that your experience? It's not my experience.
These values allow us to calculate the magnitude of the kinetic frictional force acting on a sliding object. Friction isn't always a nuisance. It can also be used to our advantage. When we walk, the static friction between our feet and the ground allows us to propel ourselves forward, rather than our feet simply sliding back.
And again, it's obviously not static friction because your feet don't just stay in one position. There's all kinds of rubber, all kinds of surfaces that are pushing on each other. They're obviously pushing on each other. They're moving. So again, it's a little iffy whether there's any real static friction there. But obviously you can't have friction if your one surface isn't moving faster than the other. And we're just talking about the differential between how fast is the stuff hitting the other stuff and how much of a differential there is. And the less differential, well, frankly, the less differential, the more you can be pushed down into the surface. The faster you go, the lower the contact.
Car tires take advantage of friction to move the car forward, and they are designed with grooves to divert water away so that it does not interfere with the contact between the tire and the ground. This allows it to maintain traction rather than skidding. We should note that air resistance is another type of fluid friction. When a car or a plane moves through the atmosphere, the particles in the air hinder its motion, offering some kinetic friction.
So
this is true of
We're just talking about anything that makes contact. What the fuck is this? Why do these videos do this crap? Or is this his commercial? Damn it. Jeez, is it switching the video? What's it doing?
Professor Dave here. Let's look.
Yeah, it went back to the beginning. I don't know why that happens. All right, then he's going to have people pushing against each other. That's going to be too obvious, right? Sorry, I haven't been watching when he's talking. I've just been ignoring the goddamn bullshit. Oh, he's on work on energy. Yeah, so it jumped me ahead for whatever reason.
Known for pursuing your passions.
Fuck, I hate
No one wants to be known for cancer.
Whoa. Yeah, I don't know what this is. It's okay. Some of this is my fault, technical issues. Anyway, this whole putting a window in a window and, you move something or something happens, you turn an ad off and you end up changing it. So anyway, my bad if there hasn't been a proper playing of the video, but whatever. So this is somewhere where we left off. Obviously, if you're in contact with other matter, it's really easy to transfer your energy to the matter. Really easy.
Viscosity of the fluid, which represents the fluid's resistance to flow.
So again, it's not resisting. It's merely saying, give me the money and I'll use it. I'll love it. Thank you. Thank you for giving me motion. And the simple truth is, to give it motion, you have to sacrifice the motion. Conservation of fucking goddamn MV. Mass and velocity. If some other mass has a velocity, it got it from somebody. Somebody had to give it to it.
So by now we are familiar with a few of the vectors we will commonly use in physics. An object at rest on a flat surface on Earth will experience a downward force due to its weight, as well as an upward normal.
So there's no normal force. It's just nonsense. It's just bullshit. It's just stupid. There's no normal force. In the sense that obviously gravity pushes you back, but it doesn't push you back with exactly the same amount of energy that pushed you in. Gravity is always one push ahead. So that's why when you sit on a scale, the scale stays compressed. It's because gravity's one push ahead.
Force that is equal in magnitude. If some horizontal force is applied, there will also be an opposing frictional force.
So there's no opposing force. Again, it's just the fact that if it doesn't have any money and it'll only... Oh, what the fuck was that? The sound turned off? I didn't turn the sound off. I didn't do it. You can say I did it, but I didn't do it.
Other out, just like the vertical ones, and the object will remain at rest. If the applied force exceeds the maximum friction, the object will accelerate in the direction of the push, and the kinetic frictional force will oppose its forward motion.
And it will always be, the frickin' force is always going to be dependent on the velocity. The faster you go, the less force gravity per foot weight you have on the surface. That means the less contact you're making, the less capacity to lose your energy to the surface. It's again a time-dependent force.
Motion. So we can expect to see these four vectors in lots of the free body diagrams.
And it's all bullshit, frankly, especially the part of any idea that friction is the same no matter how fast you're moving across a surface, because it's nowhere close to the same.
From this point forward. A common example.
It's only the same in units of time, not units of distance.
example is the inclined plane. In this scenario, we can examine a block sliding down a ramp. Gravity, represented by mg, will pull straight down, and this vector can be divided into components that are perpendicular and parallel to the incline. Those will be mg cosine theta and mg sine.
All right, so part of the gravitational force is giving you momentum down, and now you have some capacity to go down, and then part of the force is being wasted creating contact with the surface, and somewhere, you have to just wait until the line going this way is greater than the line pushing in, and then you'll move.
Sine theta. The force opposite the perpendicular component will be the normal force, equal in magnitude and opposite in direction.
So again, it's idiotic to draw the normal force perpendicular to the surface in this case, just because obviously the gravitational force is up and down, and the normal force should be always opposing the gravitational force. But whatever. To me, it's the standard should be understood. If you're going to bother writing the counter force, okay, as an actual force vector, you might as well do it in the same direction that the forces are actually moving in.
We can then include a vector for the force of friction, which opposes the other component of gravity.
So again, there's no vector, there's no force opposing, there's none of that crap. Okay, there's just the idea that you have to move mass for it to be out of your way, so to speak. I mean, if it is ice and you're, a boat trying to push through the ice, you have to have enough energy to break the ice ahead of you.
If we calculate the net force acting on the block, this will allow us to predict the acceleration on the block as it slides down the incline. And since the two
So none of this stuff is ever predicted with any kind of precision. This is all just kind of mushy physics. Bullshit. Yes, these are as a gross approximations, they're fine, but that's all they are, and they're not really getting to understanding why there is friction. Friction is about contact. Contact is exchange. That's the part that needs to be understood. This surface is exchanging its condition.
perpendicular forces cancel each other out. We just add the parallel ones together to find the net force. To try this more quantitatively, let's check comprehension.
Yeah, fuck you, fuck you, fuck you, fuck you, fuck you. Get what you deserve, you stupid, dummy, propagandizing asswipe. I really do hate this planet because you're on it. Alright, should be back. We're back to, work energy. These words are useless, okay? Work, weight, pressure, momentum, power, whatever. It's all the same thing. You're just measuring the momentum, the MV, mass moving, and the force, the little stuff moving the speed of light. Yes, it does have a mass, okay? There's no reason for you to think photons don't have mass. They impart momentum. It's clear they have a mass. They invented this zero mass photon just to do their math their way, and that's it. It doesn't have anything to do with reality. Their math doesn't work if the force actually has mass. It's just a fact. All right, and that's why it doesn't have mass. It's just because they say so, not because any experiment ever proved that photons don't have mass, the bits inside of a photon. So again, just absolute nonsense. They just preach it, you just believe it because you're stupid motherfuckers. There's no other explanation. You're dishonest, stupid morons. Again, you have to be dishonest to sit there and say, okay, I don't need you to provide me any evidence. You have to be dishonest as to not agree that, look, they have this really simple experiment they can do to prove that light is bent by gravity. Really simple. They just point a camera outside the edge of the sun, because in space there's no atmosphere, so it's dead black right next to the sun, dead black. All right, and you just watch an object and see how it moves, and if the light's being bent by gravity, then you'll see it move wrong. Okay, it's just a fact. And they can do it from space because there's 400 times. Now 400, 00, not 4 times better, not 40 times better, 400 times easier to see out there. Easier to do the experiment, 400 times easier to do, and they keep doing it from Earth, okay, and never outside a margin of what could be seen as reasonable error. You have to admit that that's crappy science. It's a 5-minute experiment, doesn't take any time at all. They have billions and billions of dollars to spend, apparently, on space crap. You think they would have done this simple fucking experiment. And no, they haven't done it. We're supposed to believe they never even tried to do it. You fall for that? Oh, fuck. Okay. So anyway, momentum landed us on the moon, not kinetic energy. They didn't use their silly definition of energy to land on the fucking moon. I think this guy knows that. I think he knows that if they calculated the kinetic energy of their thrust, that they would misunderstand how fast their lunar module is going to go, because it's not going to go. The kinetic energy won't be conserved. The object won't obey Newton's third law. Kinetic energy will not obey Newton's third law. And you won't land on the moon. He knows that. And this fucker still preaches this crap. Okay, as if it's authority. As if they've proven it over and over and over again when they haven't even dropped 4 pounds 1 foot and 1 pound 4 feet. They haven't even done that experiment. And you fuckers are defending this fucking science? God damn, you suck. Again, the suck is you. You're just pieces of absolute shit. To sit there and argue with me because I'm pointing out how you have zero evidence for your fucking religion? I'm the enemy of science because I'm pointing out science shouldn't be a fucking religion?
Just like force, the words work and energy have a variety of connotations in common language.
Oh, bullshit. So it's just more nonsense, like somebody's confused. We all know what fucking work is, okay? We all know that it's some sacrifice we have to make to do something called work. To make something happen, that we have to give away our fucking stuff for something else to have it. That's the idea of work. It ain't going to get done unless we go do it. The dishes ain't going to get washed unless we work on them.
When we say work, sometimes we mean exercise. Other times we mean a place we go every day and do something to earn money. Energy.
Yes. And again, it's work. It's where we have to take ourselves and put ourselves in some other condition. Obviously. It's changing something. We're changing the environment.
Is even more convoluted. We might say that today we have no energy, meaning we feel tired. Or we might use the term in a completely metaphorical way, saying that a person or a location...
Oh, this is just such a waste of time. So he's only going to do a 4-minute video on energy, and he's going to waste our time with this silly spiritual energy concept. What a waste of time.
...has good energy. But, once again, in physics, these words mean something very specific.
No, they don't. And what would you say they specifically mean don't mean anything. And you say kinetic energy, and that can mean either, well, active energy, energy that we can see, or it can mean 1/2 mv squared. Who knows what it means?
And if we are to learn science, we must allow the rigorous definitions to replace the colloquial connotation.
All right, so all you naysayers, he just said it. There's only one definition of energy, kinetic energy, 1/2 mv squared. Somehow momentum doesn't do anything in the universe. Somehow it's a moot, impotent force. When, of course, it's the only one that gets right answers. Every fucking time.
Work is defined as action done on an object whereby an applied force...
So this idiotic notion that the only kind of work you can do is movement in a direction. That there's no such thing as holding something in jittery gravity. There's no such thing as doing this. I push up, it pushes down. I push up, it pushes... That's not fucking work by their fucking idiotic physics. I mean, that's how stupid it is. All they care about is actually seeing something move. So if it's getting heated... That's not work because it's moving back and forth. It's jittering. That's not work. When you know it's goddamn work. If you jump off a diving board and the diving board's still wobbling up and down, well, we all know that's work.
Causes a displacement of that object. A basic example would involve...
So, and it's only displacement we decide to see. So the displacement that's really small, we don't bother with, we don't calculate, even though it's incredibly high in the sense that a fast vibration can consume a huge amount of energy. It can involve a huge amount of energy. Oh, but who cares? Because we're only going to count something we can measure with a fucking goddamn foot ruler. What a pile of shit.
Pushing a box 10 meters across the floor. Work is equal to the magnitude of the applied force times the displacement of the object.
So again, more just a silly definition, right? Doesn't have a goddamn thing to do with almost any circumstance in which you're going to do work, because the displacement will be completely dependent on how much goddamn friction there is. All kinds of factors will decide how much work you have to do to actually do one of these things. So it's completely irrelevant. The fact that I have to, the fact that moving an elephant requires more work than moving a mouse, okay, granted, no doubt about it. But there's no fucking point in sitting there saying, you're going to come up with some universal concept that it's only about how far something moves. That's how much work it was. The elephant's not going to move at all. The mouse is going to move very fast, very far. Same amount of energy. So your formula's crap.
So it has units of force times distance.
And of course, it's force times time, just like gravity. 9.8 meters per 1 second per 1 second. 1 second. 1 second, you get 9.8 increase. 9.8 meters per second increase in your velocity. Okay, in 1 second. 1. Oh, God. This is so fucking stupid. How can you people buy this crap?
If you push with a constant force of 100 newtons over the 10-meter distance, you would do 1,000 newton meters of work, which are equivalent to a...
So they'll keep telling you how newtons aren't joules, and then he just converts it right there in front of our face into joules. It's just so ridiculous. And then they'll say, we know that newtons are weight. We know that a newton is the weight of 100 grams. And then they'll say joules can't be converted into a weight. Well, you just did. You just converted a weight into joules. How the fuck can I just do the opposite? Why can't I just convert joules into weight? Oh, they're just so full of shit.
Another SI unit called joules. This means that work can only be done when displacement occurs.
So again, just kind of silly, because we know displacement, whatever the fuck that means, okay? Again, are they going to count displacement when the displacement is this way, and then it's that way, and then it's this way, and there's a whole bunch of it happening in 1 second. 1 second, something's vibrating a huge number of times, doing a ton of work. If you added up the distance that way, and you add up the distance that way, it's covered a huge amount of distance. So if they actually paid attention to the oscillatory distances, then this could work. This stupid force times distance could mean something, but they're not going to pay any attention to the oscillatory distances.
If you push a brick wall with the same force for the same amount of time as the box, you may get very tired, but technically you have done zero work.
So again, that's their physics, and you think that's a rational statement, that you didn't heat the wall, that you didn't actually do work on the bricks, you didn't vibrate them and move them, you might have crushed a couple of surfaces, you might have knocked some pieces off. Come on, we know you did work on the wall. There's no way no work was done on the wall, and clearly you know you did work on your own goddamn hand, and your fucking hand will be white, and the blood will be out of it, and it got squished out, and you might have crushed some of your goddamn fucking cells. You might have actually done some damage. No work was done. Bullshit.
In addition, only the components of the applied force that are parallel to the displacement are considered to be contributing to work. If you push the box...
So again, that doesn't even make any sense. If you push the box and the floor gets hot, that doesn't count. Well, of course it counts. You had to make the ground hot. The ground didn't get hot for no reason. You made it hot by pushing the goddamn box. Fuck. This is so bad.
With your arms parallel to the floor, all of your effort contributes to work done on the box. But if you are pushing at a downward angle, only the X component
Well, in that case, but again, it's still all work. And obviously when you're pushing down, you're not doing work against gravity, so the better example is you pushing up, because then you have to do the actual extra work of lifting the object.
Contributes to work, while the Y component does not. In such a scenario, instead of using W equals FD, We could calculate the work done on the box using W equals FD cosine theta, as this will give us the portion.
Again, it's the wrong definition of the total work, so they're not even going to get the total work because they're not counting the heating of the ground. So they're not counting the friction or anything else. They're just counting some displacement of a mass in a direction and saying that's the only part of it that was work. And everything else we're going to just ignore. So even though you applied 10,000 joules of energy to the fucking box, the only part they're going to count is the 400 that went in the right direction. Which is just bullshit. It was obviously all work.
Portion of the applied force that is operating in the horizontal direction. If theta is 0, meaning the applied force is horizontal, cosine theta will be equal to 1, leaving us with...
It's all the same physics. The ground getting hot is the same physics as the box moving, okay? It's the same. It all should be understood and calculated and counted. You should never sit there and say, I'm going to sit there and apply a momentum, and then I'm not going to bother accounting for where it went. And it's just a simple argument. You could say, okay, the guy is 33% efficient in pushing a box because only 33% of the work went to moving the box. The other 66% went into heating the ground. Now that would be honest.
W equals FD. And if you were to push straight down on the box, theta will be 90 and cosine theta will be 0, meaning no work is done.
So it won't even work. That calculation won't work because obviously when you're pushing down on the box, you're going to increase the friction, and so you're not going to move the box. Just a fact. You're going to increase the friction. The box isn't going to move. So you're going to have instead of 33% of the energy going into moving the box, it'll only be 15%, and now you have 85% of the energy wasted. That's going to be the actual fact. The calculations won't get the right answer because there's nothing proportional about it. And again, every single time you push down and create more contact with the surface, it depends on what surface you're pushing your fucking box on. So none of these formulas actually calculate anything real.
On the box, and it will not move. Any angle in between, and there will be some motion. We must bear in mind that work is a scalar, and it can be positive
or negative. So again,
more
nonsense about some sort of scale. Oh, I hate this fucking. I wish they'd get rid of these forward and backward buttons. God damn it. I hate it.
At Harbor Freight, we design and test our own.
Back. Jeez. Scalar bullshit. So again, just the whole invention of this nonsense that there's any such thing as hidden bullshit energy or whatever the fuck they use this stupid scalar crap for. There's absolutely no reason for anybody to think there's any physics that involves moving something in any direction. Anything that moves has to move in a specific direction, especially in the elemental universe. There is no such thing as movement in some arbitrarily undefined direction. It's just such crap.
Mind that work is a scalar, and it can be positive or negative.
Oh, and again, this whole idea that there's any such thing as negative work or negative energy or negative any of that crap. Bullshit. Negative heat. No, there's no negative heat. You either got some or you got none.
Work will have a positive value when the applied force is in the same direction as the object's motion, like when pushing the box.
And again, if two people are pushing on the box, there's certainly going to be plenty of work being done. So they're both pushing in opposite directions. You know there's lots of work being done, lots of calories being burned, lots of heat being created. So it's just a big fat fucking lie to say, it canceled. It didn't cancel. That's why the core of the earth is molten. That's why the sun is on goddamn fire, is because when forces are pushing against each other, it's real energy and it has to go somewhere. And the only place it can go is be converted into little shit jiggling.
And work will have a negative value if the applied force is in the direction opposite the object's motion, like if your baby brother pushes the box the other way, but without enough force to stop it from moving forward. The sign on work is very important because
it's stupid and ludicrous, and obviously you could just talk about it as an, okay, motion has a direction, and you can counter a motion with a counter motion, all right, but you still can't say it cancels. You can't cancel energy.
because it tells us if the speed of an object will increase or decrease as a result of applying the work.
Yeah, the speed, not the velocity, the magical speed. So, it's just such bullshit that there's somehow when you're doing work, it's a speed, and when you're doing something else, it's a velocity. It's just bullshit. Game playing nonsense. It's all part of their fake shroud of Turin physics.
Energy, another elusive term, is quite simply the capacity to do work.
So again, more bullshit that's their definition, because that fits momentum just fine.
And this is summarized in the work-energy theorem. This states that when work is done on an object, there will be a change in that object's kinetic energy.
So again, what's the kinetic energy now? So it doesn't mean the active energy. That doesn't mean it's momentum. No, that means it's 1/2 mv squared. And again, that's the bullshit, because that will not be conserved. And these fucking times you transfer the energy from large things to small things, or from small things to large things, from one bullet going 1,000, from one atom going 1,000 miles an hour to 1,000 atoms going 1 mile an hour. Anytime you do those transfers, okay, kinetic energy isn't going to be conserved.
Which is the energy of motion. This also means that an object in motion is able to do work.
So again, the bowling ball and bowling pin argument, when that is what just illustrates how their physics is all absolute lying bullshit. Again, how much time does it take to think about it? Your physics is basically saying the lighter I make the ball, the faster it's going. Okay, same exact momentum. All right, but I just make the ball lighter and make it go faster. Somehow I have this quadratically increasing amount of energy, and I can knock down more and more pins. And the fact is, no, the momentum's going to knock the pins down. When the ball hits the pin, each interaction is going to be a momentum exchange. That's Newton's law. The third law will be obeyed when the ball hits the pin. Okay, kinetic energy won't be obeyed. That won't be conserved. So the whole thing is a farce. It's so fucking stupid.
Work on another object. The work-energy theorem brings together concepts from Newton's laws and
it's not Newton's physics, okay? It's Leibniz and Huygens physics, okay? They're the ones that put this fucking square on the velocity. They're the ones with the delusion that 4 pounds dropped 1 foot is the same as 4 pounds dropped 1 pound dropped 4 feet. They're the ones with this delusion, okay, that's about distance and it's not about time. Newton was about time. Newton wrote the third law, which kinetic energy constantly and always violates every single time you're applying forces to objects of different masses. You will end up with an inequity. You will not resolve, you will not conserve the thing called energy.
Kinematics to describe motion in a way that we will examine further in the next clip. For now, we must simply purge ourselves of any prior connotations of the word energy.
It's just such bullshit. No, what you would need to understand is energy is just motion, and the only thing about motion that's interesting is how much mass is it. Big elephant moving towards me, little mouse moving towards me. Which one's got a chance of doing any damage? That kind of bullshit. Literally, it's as simple as one atom moving 1,000 miles an hour, 1,000 atoms going 1 mile an hour. Same capacity to move stuff in the universe, same money. Okay, and that's all there is. It's a currency. Motion is a currency. Things have the currency. Things can give other things the currency. They can share it with them. They can spread it on them.
And understand that it merely describes a property of an object or system that can be transferred into another object or system.
And it has to be conserved. And kinetic energy isn't conserved. In 99.9% of real interactions in the real universe, kinetic energy isn't conserved, because very few interactions in the universe have to do with the same thing hitting the same thing.
Often in the form of work. There are different kinds of energy, including kinetic and potential energy.
So there's no such thing as potential energy. There's just storage. There's just trapping energy in circles, or trapping energy in this kind of motion, trapping energy in pressurized vessels. You can trap energy, but there's no potential energy.
Energies, thermal energy, chemical energy,
Again,
and more.
thermal is obviously
Old Spice
just
Gentleman
motion.
Super Hydration
Damn
Bar.
it. I hate this fucking thing. I should be back. God, why I don't need a forward and back button. Why are they, the play button seems like it's very small and these other fucking buttons are very big. YouTube just wants these fake clicks.
Energy, chemical energy.
Sells more ad revenue, right? They can just lie about how many impressions there were. Oh yeah, it was the fact that they hit that button by mistake. That's all it's there for, you know. That's the reason why they've wedged the play button, this little tiny sliver inside of these other two fucking jackass buttons.
Energy, and more. And we will discuss all of these when the time comes. Once again,
So again, thermal is the same as any other kind of motion. It's just it's motion in small things. It's small atomic motion, period. Same damn thing. It's mass moving. You just calculate how much mass, how much fucking goddamn velocity. Not that complicated. Fuck you. You're just so full of shit.
SI unit for energy is the joule, which is defined as a Newton meter. Even though
Even though none of that makes any goddamn sense when it's all just a weight. Okay, so the joule is the weight of a kilogram. That can't be right. We know the Newton is the weight of 100 grams.
energy is not always transferred in the form of work. But our understanding of energy will grow as we examine the various types of energy.
La, 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 la. I'll help you be an asshole like me. Be a good Christian little soldier. Be a little fucking dupe, sucker, fool for bullshit, nonsense, wooey, religious crap dogma. Again, where they've done no experiments. They can't show you a shred of evidence that it takes 25 times the fuel to spin something 5 times as fast. Not one shred of fucking evidence. And yet they'll claim it's the truth. According to them, these pontificating, obnoxious, patronizing, arrogant fucks. We are smart. We went to fucking college. Yeah, fuck you. Fucking goddamn religious shit brains. You didn't do any thinking on your own. You just memorized the fucking goddamn crap they told you. You tattoo it on your fucking arm, you fucking idiot. You're just such an idiot. What the fuck is that anyway? Banjo? I don't know. They're all fucking goddamn banjo players. This is living deliverance. I mean, I'm living on a planet of goddamn fucking... I mean, you just can't be wasting this many neurons. You know, just... without there being some kind of bullshit to blame. I mean, how the fuck do you get your brain to be fucking so stupid that you believe this crap when you haven't seen any evidence? Why do you believe in quarks? Where did they show you a fucking quark? Ugh.
So let's move on to that part of the course.
Thanks for watching, guys. Subscribe to my channel for
Dupes, listen to this shit science. That's all it is. Shit. Garbage, crap, nonsense. Religious garbage.